Okay, so we're going to combine stuff from last unit with this unit. Okay, you ready? I'm going to look at my algebra branch here. Okay, one variable? Nope. I have two variables. My two variables are a sine theta and a cosine theta. Those are two different things. So I'm over here. I got to make sure it equals 0. Check, it does. Okay, let's go through our factoring list. Do you see any of those factoring styles? Do you see any factoring styles? It is there. Which one of those four styles would that one be? Does it look like a GCF, difference of squares? Does it look like a simple trinomial or a complex trinomial? Did you pick GCF? So this is a GCF. What could you take out of each term? So this is a term, and this is a term. What is common to pull out? Each term has a cos theta, right? If you divide a cos theta out, what are you left with? 6 sine theta. What do you have in this? When you divide it by cos theta, what do you have left? 1. By the way, you can always double check because those should multiply back to the front, right? Does this multiply back? Yeah. Okay. So I'm going to deal with this and this. I'm trying to make it 0. So my variable is cos theta. I want it to equal, if I want that to be 0, cos theta would have to equal 0. And if I want that bracket to equal 0, do you remember this? This is last unit. I want it to be, it's going to be a fraction, something over something. Do you remember how to do that? -1/6. Right? Does that look familiar? The only thing different now is my variable is not x or y or whatever. Okay, you ready? Cosine is 0. We just talked about this one, but okay, 0 is not positive or negative. So you're not in a quadrant. So you could have any of these 5 angles work. Which ones are going to work? So if you want, you could test them all. So like this, like cos of 0. Nope. Cos of 90, cosine of 90. Oh, there, that makes a difference. Cos of 90 equals 0. So 90 degrees works. And 270 also works. Okay, and we also just talked about this. The cosine quadrants split up, positive, negative, so where's cos 0? In the middle of it. Okay. Sine is -1/6, sine of the angle. Okay, where could my angle be? Which two quadrants could my angle be in? The bottom? Is that what you picked with the Astica stuff? The bottoms? Okay. Now I'm going to go into angle mode. I need angles now. How do I start with angles? I'm going to have to sign inverse, right? Because that's how you get angles. And what's that little rule? Don't put the negatives in the math. The negative is inside the drawing. Okay, so can you get a number there which is called your reference angle? That's a reference angle. Okay, so 9.6 degrees is a reference. All right, now I need a final answer there. Okay, so this one, do you understand you're going 9.6 more than 180? So you're going to add with the 180. And here, your 9.6 smaller than 360. Okay, number 2. Here's another question for you then. I got 3 questions altogether today. Okay. Ready? I'm looking at my strategy. This is how do I start a problem. Algebra, do I have one variable? Nope. I have sine squareds and sines. It's like having x squareds and x's. Okay, so I got to set it to 0. Do I see any factoring styles? What do you think? Does that look like anything? Does it look like a complex trinomial? Right? Because you have some amount of x squareds, x's, numbers, like that's the trinomial. Okay, let's try it. Complex trinomial. So how do I start a complex? I go fl, which is positive 12. 1, 12, 2, 6, 3, 4. Is there any way I can multiply to positive 12 while adding to negative 13? Do you see anything that would work? And the answer is yes, you do have something. So at this point, I can say that this is indeed factorable. It's going to work because I found a pair. Okay. So how do I produce the first? I'm going to need a sine theta times a 3 sine theta. That's the only way to do that. How do I produce the last? I could go 1, 4 or 2, 2. Okay, you got to find partnerships to make a 1 and a 12. A 1 and a 12. Okay, so I'm going to set it up. 2 brackets. So I'm going to go sine theta, 3 sine theta. because that's my 3 sine squared theta. Okay, I'm going to draw like swivels like this to be an O pair, an I pair. So I did sine with a 1 and 3 sine with a 4. Do you see my out and my in? That makes a 1 and a 12. Together that's going to make 13. Okay, so this is nothing new concept-wise. You're doing your complex trinomial. But here is where it all switches. You ready? Sine theta equals positive 4. Sine theta equals 1 over 3. Normally this is where we would end. But it's not, because all you did was solve for a trig value. So now we have to go into the whole angle process. Okay, so here we go. 4. Trig value, positive, sine positive. I'm going to sine inverse 4. And I get an error. So what do you know about the angle in this situation? If you get an error like that, what's the answer for the angle? There's no solution on that. There's no angle that's going to work. Okay, I'm done that. Let's go to this one. So for a trig value of 1/3, sine is positive 1/3. So I pick my quadrants. Sine is positive. I'm going to sine inverse 1/3, like that. My brackets would be important for me there. Okay, that is not the answer. That's just your reference. So, if you go 19.5 degrees bigger than 0, you're at 19.5. And if you go 19.5 smaller than 180, okay, one more. Okay, so going through my algebra stuff in my head, well, it does not have one variable to isolate. Okay, there's two variables because I have a tan squared and a tan. Do I want to try factoring first? Let's try. This would be a complex trinomial, right? Okay, the FLA is -8. The FLA is -8. 1824. Is there anything that's going to get you 3? Do any of those pairs make a 3? 1 and 8, that'll never be 3. 2, 4, that could never be a 3. So, guess what? It's not factorable. What am I going to do if it's not factorable? What did we say in our process of thinking? If something doesn't factor, what do you have? You have that formula. Okay, so tan theta equals instead of x equals, I have tan theta equals, because that's my variable now. Right? Instead of x squared, I have tan theta squared. Instead of x, I have tan theta. Okay, are we ready to try it? Negative b, so the opposite b number, so positive 3. B squared should make 9. Subtract 4 times the 2 times the negative 4. All over 2 times a 2. Okay, so I'm obviously going to jump to my calculator because I would like what we've been calling the discriminant here. I want to figure that out in my calculator right now. 9 subtract 4 times 2 times negative 4. Okay, can you get me 2 decimal values? You remember how you're going to type it? That's what you're typing, right? Do you remember this from last unit? 3 plus root 41. Okay, how are our digits looking here? 2.35? I added and got that, and then when I subtracted, I got negative 0.85. It's good. Okay, we are not even done. We're like halfway done. All we did was found the trig values. So now I still have to go into the whole process of figuring out the angle solution. Okay, so this is just a trig value again. Don't stop. What's the angle? Okay, so here's the process. Quadrants. So I'm just looking at the 2.35, tan positive. Okay? So quadrant 1, 3. Tan inverse it. Tan inverse 2.35. 66.9 degrees. That's a reference. That's not an answer, it's a reference. Okay, so 66.9 is one of the answers. And the other one is bigger than 180. Bigger than 180. Okay, and now we're going to have 2 more answers yet to this problem. Okay, so tan is a negative 0.85. So negative tan quadrants. Negative tan quadrants. And what are you doing in your calculator here? Do not put the negative in the calculator. Okay, your negative is attached to the drawing, not in the math. Can you finalize your answers? I got a reference of 40.4. Can you figure out where you are? So a final answer.